Hey guys, we are just doing a quick little 6162 thing before break. So let's take a look at the 6-1 notes. One of the things your teacher should have given you is this chart. Mine's repetitive, sorry, because this is what we turn in to have it like copied back to back. So keep in mind that when you're finding the roots, you're finding something smaller. You're saying, hey, what's the square root of 4? 2, because 2 times 2 would be 4. Cube root of 8 means what times itself 3 times would be 8? And the answer is 2, because 2 times 2 times 2 is 8. So we've been studying exponents. So the opposite of like 2 to the third power, which means 2 times 2 times 2, which gives you 8. The opposite of that is to say, hey, what's the cube root of 8? And you think backwards to get that 2, meaning what did you have to multiply 3 times? So when you look at something like this, the fourth root of 256, that means what times itself 4 times became 256, and that would be 4 times itself 4 times. And then down here, this is more common, like 4 to the fourth is 256. So those are like the opposite of each other. 4 to the fifth is 1024. So the fifth root of 1024 brings you back down to that 4. So we're going to be using that table just as a quick reference when you can't use your calculator or if you don't know how. So, all right, let's take a look here. Nth roots. So you have like the square root we're all used to, but sometimes there's a number in there, and that number in there is called the index. It's telling you how many times the number had to repeat. Square root, it had to repeat twice. Cube root, it had to repeat 3 times to get the number underneath the square root sign, which is called the radicand. So that is the radicand, and that is the root index. If there's nothing written there, we assume it's a square root. So for example, this is the index 5, and we'd be looking for something that goes 1, 2, 3, 4, 5. It multiplies by itself 5 times to give us a 32, which is the radicand. And by the way, if you look at your chart real quick, you would say, okay, I'm looking for the fifth root of 32. So this is in my fifth root column. Fifth root of 32 is a 2, meaning that 2 times itself 5 times would give us that 32. Okay, this is evaluate. Evaluate always means to find the actual number. Without a calculator is going to mean that you're using your chart. So this one's saying what number times itself 3 times would give me 64. And if I go to my chart, I can find on the chart, this is going to be annoying, but I'm going to keep going back and forth. I'm looking for the third root. So I look at my third root column of 64, and it's saying the third root of 64 would be 4, because 4 times itself 3 times would be 64. This one doesn't have an index, so the assumed index is a 2. Square root of 25, you probably already know. And again, that's because 5 times itself twice per this index would have been 25. Okay, don't let this one freak you out. First thing you do is you square the 4. 4 to the second power is 16. And then I can go and look at my chart and see what is the fourth root of 16. And that's going to bring me back to a 2 again. Because 2 times itself 4 times would be that 16. So just like powers and roots are the opposite. Okay, so here I have an index or a root of 4, but then a power of 3. And I always do the root first if I can, because then the number gets smaller first. So if I go to my chart and find the fourth root of 81, I got to go to my fourth root column, find 81, and the fourth root of 81 is 3. So this becomes 3, and then to the third power, which you can use your power chart to find. But that part's not as confusing because we're used to it. And that simply means 3 times itself 3 times. Okay, how about here? This is going to be a square root. Do the root first. You guys know the square root of 16 is 4 probably, and then do the power. So I would write myself a little note. It's best if you do the root first, especially if you're stuck doing the problems without a calculator, because then the number gets smaller before it gets bigger. So this inside became a 4, and now squared brings you back to 16, which kind of makes sense because you have a square root and a second power, and they will cancel out, leaving you with 16. My dog's about to make some noise, it sounds like. Always got to weigh in on these math notes. Okay, so rewrite the rational exponent. All that means is fraction. Using radicals and evaluate. Okay, so if you have something, some base, in fact, I'll leave it as next. You're gonna have like a power over a root. I always think of it like in a plant. The root would go on the bottom of the plant. P for plant, P for power. So if I have this base, the root index goes here, and then the power goes out here. Sometimes they have it written where the power is on the inside. But either way, you can rewrite it as a fraction power, or you're going to have to, unfortunately. Got to be able to go back and forth. But I would, again, remind you that it's probably best when you're finding the answer to do the root first. So here, this is my root index, and this is my power. All I'm doing here, the verb says to rewrite using fraction or rational powers. Using a radical. So I would write my 9, and then technically it's to the first power and the second root, but we don't write things to the first power and we don't write the second root. We just would write it like that. And so it says using radicals and then evaluate. So now I need the actual answer, and the square root of that would be a regular 3. So again, bottom is the root and top is the power. So I'm going to have the 6th root of 64 raised to the first power, but we don't really write it as raised to the first power, so I would just write it like that. And then I can go to my chart to evaluate that. I'm looking in my 6th root column, which is over here, and I'm looking for the 6th root of 64, so my answer again is 2. In terms of evaluating. All right, so root on the bottom means I'm taking the square root, and then cube on the top, the power is on the top, so that's going to be to the 3rd power. I wouldn't really need to write this because without it we still assume it's a square root, so this becomes 5 to the 3rd power, and then that turns into, on my power chart, 125. So there's not, like, this is the radical way to write it, square root of, and then raised to the 3rd power, but we end up at 125. Same thing here. Bottom thing is the root, and then this would be a power of 1, but we wouldn't write power of 1, so we would just write it like that. And then I can't evaluate that because it doesn't have a number. This one, the bottom is the root, top is the plant or power. So I'm going to have a cube root and then square it. So I'm going to go to my chart, find the cube root of 8, which is a 2. Then I'm going to square it, which comes out to be a 4. So fraction powers really aren't fractiony. They're just two things and are telling you to find them kind of in a different order. All right, I'm looking at the filled-in notes, and she has totally different problems than here. I'm wondering if I have the wrong notes packet. I certainly hope not. Okay, well, I'll just go for it. Hopefully most of them match up. All right, so we have already talked about this. Rewrite meaning if I have a fraction, we're just kind of going the opposite way. Like now, if I have my base, whatever it is, raised to a power with an index for a root, that is the same as if I have that root index and then the powers on the outside, which will be power on top, root on the bottom. So basically above, we started with this part at the end, and now we're just starting at the opposite end. We're just practicing going back and forth. So we're still going to rewrite, but go the other direction. So now I just think, okay, this is 81, and then I have a 3 as a power and a 4 as a root index. So it would go 3 over 4. And then in terms of evaluating it, I still like it in this form because I can look on my table, find the 4th root of 81, which is 3, to the 3rd power is 27. So when I have to actually find the answer, usually use the radical form. This is going to be a 2 since there's nothing written. So that could be written as 16 to the power over root index. As it stands, I would take the square root of 16 first and then raise it to the 3rd power. Looking on my chart, that's a 64. So this is the rewriting part, and then this is the evaluating part. All right, this one, again, I'm going to have my base. This is a power, so it goes on top. This is the root index, so it goes on the bottom, and I can't evaluate that one because it's just an X. Whoa, this bottom thing looks confusing. It basically is the same as having 1 over the 5th root of 32, that whole thing squared. That's what that's supposed to be showing you. So this one's a little tricky because not only do I have to say, hey, 32 had a power of 2 and a root of 5, but it was on the bottom. So I'd actually have to do it to a negative power because that's what brings stuff to the bottom. But to evaluate that, I would again look back at the radical form and be like, okay, I'm 1 over, and then the 5th root of 32, according to my chart, is a 2, but then I still need to square it. So I get 1 over 4 when I evaluate to find the actual number. Now this is the same as square root of 4 all to the 5th. Also the same as the square root of 4 to the 5th. So since I have a 5th power and a 2nd root, it looks like that. But if I actually, sorry, my dog makes the weirdest noises. If I did the square root of 4, I'd get a 2, and then raising that to the 5th power, I'm just using my power and roots chart, I end up with 32. So this is the rewrite part. I'm just rewriting it as a fraction power, and this is the evaluate part where I have to actually get a number for it. Okay, now I'm going to rewrite and then evaluate with a calculator. Okay, so you're going to actually have to type this in your calculator. So rewriting, you can put this in your calculator a couple different ways. If you do 27, then use this arrow up key, and then you have to tell it it's to the 1/4 power. Some of you have a newer calculator. If you have a graphing calculator, it actually shows it up in the power. If not, you would need parentheses to say, hey, that whole thing is the power. Or you can rewrite it and say, hey, 27, I have a 1st power and a 4th root. And what you want to look for, and if you have a graphing calculator, you're looking for it under the math key. If you don't, you're just going to have to dig around and look on your calculator to see where this is, that it allows you to put in whatever index you want. And so if that's what you have to type in, usually on the graphing calculator, I have to type in the 4, then find this X root, and then I would type in the 27. I think it's easier to just type it in using a fraction power, to be honest. And so I would go ahead and do that, and I get 2.28. Check on your calculator to make sure you're actually going to get that. Now it does get tricky because you want to remember that you cannot take the even root of a negative number. That is going to be no solution. Just like we don't take the square root of negatives unless we do an I, but we're not doing I right now. So you only can take odd roots. If you try to take an even root of a negative, it's going to give you it's going to give you an error. But here, the root is the 3 and the 4 is actually the power. So if I was going to type this in, I would type in -7, and then I would raise it to the 4/3 power. So it's going to take a cube root, and since the root is odd, it'll go ahead and give me a negative answer. But if you do a -4 times, like -7 times itself 4 times, those are going to actually all cancel out because these two become positive and these two become positive. So when you do this, you actually get a positive answer out of your calculator. And again, understand it and also be able to do it. Here I have 4 as the root because it's in the index spot and 5 as the power. So I either can type in 81 raised to the 5/4, which is what I would do, or I can figure out how to navigate, typing it in like this. Go ahead and try that. This one actually comes out whole. There's a 4th root of 81 you could find on your chart. So you actually get 243. This one you would have been able to do on the chart. This is going to be 7. My power is 2. My root index is 3. So I would type it into my calculator like this. 7 raised to the 2/3 power. And you'd get 3.66. So try that. Here, this looks like it might be a problem, but it's not because my negative root is a 5, which is odd. And so I'm going to change this into a power of 3 and a root index of 5. And I'm going to type it into my calculator. I'm going to use parentheses to make sure that that negative gets sorted out correctly. And when you do that, it's going to find the 5th root of -32, which will be negative, and then raise it to an odd power, and you actually end up with -8. You would have been able to do this one on the chart too. Now, we're going to solve and give exact answers. That doesn't make any sense. You can't round to the nearest hundredth and have exact answers. So we're just going to ignore that. So I need to get the power or the root part alone. I'm going to divide by -3. So now we have x to the 6 equals about -0.283. Okay, to get rid of this 6, I would actually have to put in a 6th root to both sides. Here it'll just cancel. You're going to get an error over here because you're trying to take, like I said earlier, the even index of a negative number. And so this one is telling you there's an error because that one has no solution. That's a terrible first example, but we'll live with it. Here I'm trying to get the x part alone, so I have to get rid of a 1/2. I can do that by multiplying both sides by 2. So I have x to the 5th equals -128. So I can get rid of that in a couple different ways. I either can use a 5th root to both sides, and this one's not going to give me an error because my root index is an odd, not an even with that negative. Or you can say, hey, to get rid of this 5, I need a 1/5 power. So over here, I'm going to take -128 and raise it to the 1/5 power. And when you do that, you're going to end up with a -2.64. And it's okay to get a negative answer because my roots and powers were odd. Here, this one, I have to get whatever parts to the power alone. So I'm going to go ahead and divide that 2 out. And now x plus 8 to the 5th equals that 57 divided by 2, which is 28.5. So now to get rid of that 5th power, I either can use a 5th root or I can raise both sides to the 1/5 power. This side I don't have to do anything because the 5 and the 1/5 cancel. So I end up just with having that x plus 8. And then on my calculator, I do 28.5 to the 1/5 power and get about 1.95, which you should definitely check that you know how to do that. Still trying to solve for x, so this one has one additional step. To get the x alone, I have to subtract that 8, and when I do, I get -6.05. Okay, this last one has a few steps to get the x part alone, because I'm trying to get this part that's to the power alone. I'm going to start by subtracting 4 over to the other side. Now I still have these things left, and over here I have a 105. I'm still trying to get just this part alone, so to get rid of the 5, I'm going to divide it out here and here. So now I finally have the part that's raised to the power alone, and this becomes a 21. And then I'm going to, wait, I changed that to a -4 inside for no good reason. I must have been looking at the power. Sorry about that. Okay, so x minus 3 to the 4. So now I'm going to, I'm digging out my calculator, sorry. I got to get rid of that 4 power. I could use a 4th root, or I can think of raising it to the 1/4 power. That will cancel that power out, and I'll just have x minus 3. And then if I do on my calculator, if I do 21, and then I raise that, sorry, I'm trying to figure out my calculator, to the 1/4 power. I don't have my calculator at home, so I'm using my phone, and I'm super bad at it. I get about 2.14, and then I need to add 3. So x equals 5.14. Okay, which is different than the filled in notes, by the way, but I see she wrote 21 here and then dropped it. So it's not a 21 anymore. She just made it into a 2. So anyway, this is the proper process. So there's a lot of tricks in there, but you just kind of have to get used to something as a radical and how could you write that as a fraction power instead. And sometimes that'll turn out to be a lot easier. Hope that helps.